To have interfaces is good because they provide an abstraction layer. One can use the methods provided without having to know how they're implemented. But at some point, these methods have to be implemented. At some point, someone has to look under the hood. Let's see how this works and what topics come up. So imagine we have an interface called vehicle.if. This interface has a number of methods specified. Remember that they are public. We might implement a class for this interface and call it vehicle. Notice now the keyword implements instead of extends. To implement an interface means defining a class where for all the methods we give implementations. We define bodies. We might also define attributes and constructors and additional methods, possibly private ones. The class follows the specification given by the interface and adds concrete details on how the methods might work. However, we don't need to go from the interface specification to the class implementation in just one go. We might also proceed in a stepwise way. The way from the interface to the class that can be instantiated can be shorter or longer. We have the conceptual tools to help us as needed. Let's revise the possibilities of implementation and inheritance. First, we might extend an interface to another interface, for instance, by adding abstract methods, as you see on the left image. Then we might partially implement an interface by giving bodies to some of the methods. In this case, we get as a result not a class but an abstract class, because not all the methods are implemented. And finally, we might go directly from an interface to a class by implementing all methods. For completeness, let's remember the other possibilities for extension. If we have an abstract class, we might extend it to another abstract class, for instance, if we implement some of the abstract methods, but not all of them. Or implement it to a class, if we implement all methods. Finally, let's remember that we can extend a class to another class. This is the inheritance relationship we started with. Now, a very interesting idea is that an interface like the one we have defined before serves as a specification not just for vehicles, but for many other objects that have the ability to move forward, backward, and have a string representation. For instance, a robot, or a character moving in some space, as we have seen in previous examples, an animal, or whatever moving thing. Now we have changed the name of the interface to movable to reflect this idea. This is the power of interfaces and the conceptual aid to help us model systems that allows us to reuse not just code, but also concepts. Now, one important thing is that the class can implement not just one, but multiple interfaces. In this case, the class has to implement all the methods from all the interfaces. Remember that the class could not extend multiple classes. There is no multiple inheritance in Java, as there is in other programming languages, such as C++. A class cannot be extended from two classes. However, there is no problem in Java in having a class implement two interfaces. This is a way to say that an A is a B and a C. For instance, we could define an amphibious vehicle as an implementation of both of a vehicle interface and a boat interface. This amphicar would implement methods from both interfaces. Now, when doing so, there might be some name conflicts. What happens if we have the same method name in both interfaces? Here's how it is solved. If we have the same method name in both interfaces and return types are different, then there's an error. This is not a legal possibility. If method name and return type coincide, then we are fine. If, moreover, the parameter types coincide, then the class has to implement once this method. They are indistinguishable in the interfaces. If the parameter types don't coincide, we have a case of overloading, which is treated in the same way as if they come from one interface. Both have to be implemented. We might also define a class by implementing an interface and inheriting from a class at the same time. So implementation and inheritance relationships help us to define a structure of related interfaces and classes that help us to do programming in the large, that is, program complex systems in an overseeable manner that helps us also in their evolution and maintenance. I have this remote control. I've always wondered how these remote controls are built inside.